This is video 4.1.1, and the goal of this video is to be able to convert between radians and degrees and write angles in standard form and find coterminal angles. So some of this you've already seen a little bit in class, but now we're going to look a little bit more in depth at how we're going to be using radians in this class. So first of all, some vocabulary. A couple of key things, and it should kind of logically make sense, but when you hear the book and me talk about different vocab, here's the things that you need to know. The initial side of any angle will always start on the x-axis. Okay? Now, when we open up angles, we always open them up counterclockwise for positive angles. And the other ray that's on the other side of the angle is called the terminal side. So initial to terminal, and we always start at 0, 0. I'm sorry, not 0, 0. We always start on the x-axis, on the positive x-axis, and we open up counterclockwise. Now, notice that when we have positive and negative angles will open up counterclockwise, as you see here. They're opening up counterclockwise from the x-axis. Negative angles could open up clockwise. The right-hand side is a negative angle because it opens up clockwise. So if I estimated this angle over here, it would be about 115 degrees, maybe a little bit more than 90. And the one down at the bottom is actually like negative 115 degrees. Okay, so it's the same size angle, it's just opening in a different direction. So direction matters during this unit. So now if I want to draw 225 degrees in standard form, I would start by drawing my axes. And then I would draw the angle. So I know that this is where I start. That's the initial side. And now I got to find the terminal. So let's see, this is 90 pointing up. But I want to keep going past 90. This is 180. And it looks like I want to go 45 degrees farther than 180. So 45 degrees is halfway. This angle right here, going all the way from the initial side to this terminal side, opening counterclockwise, is 225 degrees. Because it's 80 plus 45. 180 plus 45, excuse me. So that's drawing angle 225 degrees in standard form. You're going to practice a little bit of that in class, but more so you're going to be reading graphs. So be prepared to use that terminology in class this trimester. So again, what is a radian? Radian, so first of all, the first definition that you should have recognized in class was that a radian is the measure of a central angle of a circle that intercepts an arc whose length is the same as the radius. That's the definition that I would like you to use. This is the definition that the book uses, and it's an important understanding that we're going to use for the next example. But the definition that I want you to use, it's the measure of a central angle of a circle that intercepts an arc whose length is the same as the radius. That's the reason we use the word radian. That's where that word, of course, came from. Now, one information that you need to understand is that for any angle theta, the number of radians it will be is always s, meaning the segment length here of that arc, divided by radius. Because we know one radius would equal 1 radian, so therefore s radiuses would equal s radians around that circle the angle would open. So that's the first relationship you need to know, where s is the segment on the circle and r is the radius, and theta is the size of the angle in radians. Now let's take a look at what that means for this first example and some problems that you'll be doing in class. So if I know that this particular arc is 20 inches and the radius is 5 inches, the question is, what is the radian measure? Well, that is always equal to the segment divided by the radius. So I'm going to do 20 divided by 5, and I get 4. And that should make sense because, of course, 4 radiuses would fit to fill that 20 inches. Therefore, it's 4 radians in size. That's the size of the angle, theta, that goes from the initial to the terminal side. So we'll be doing a few examples like that, but more will be applying stuff like that in the long run. Now, to review what else we learned in class, let's review how to find and convert from degrees or radians. So we're just going to do 2 examples just to review to make sure you have the notes down. So we have 2 methods to convert, but one relationship that we always have to memorize, that pi radians is equal to 180 degrees. So to convert from degrees to radians, we always multiply by pi over 180. And of course, to go backwards from radians to degrees, we do 180 over pi. Okay, and of course that's because degrees is on top and radians is on bottom, and vice versa for the first one. The proportion method will work no matter what, but we'll always just set up a proportion with 180 over pi. So I'm going to show you both methods for these 2 examples. So negative 150 degrees. With the dimensional analysis method, I would simply do negative 150 times pi over 180. Because to convert from degrees to radians, I always multiply by pi over 180. Now, my next thing is just to simply simplify. So it's going to end up with negative 150 pi over 180. I'm going to simplify top and bottom by dividing top and bottom by 30. I think that's the largest common factor. So I'm going to get negative 5 pi over 6. This is my simplified answer. So that's converting using dimensional analysis. But if I want to use ratios, I'm looking for the number of radians. I'm going to set it up as a proportion. Pi over 180 equals x over negative 150. And to solve this, I could use cross products, but I'm seeing something simpler that I could simply multiply both sides by negative 150 to cancel it out on the right-hand side. So again, I would be left with negative 150 pi over 180, and it would give me the same answer as I see here. And of course, you can do cross products. I didn't do that because whenever x is on the top, I like to do a simpler way, but you could have done cross products here. So let's look at radians to degrees. So now when we go radians to degrees, we're going to use the method of timesing by 180 over pi if I'm using dimensional analysis. So I'm going to do 5 pi over 8 times by 180 over pi in order to turn it into degrees. I'm going to do some simplifying as I go. I can see that can cancel. I also see that I think 4 goes into both of these. 4 goes into 180. 4 goes into 8 2 times. 4 goes into 180, let's see, 45 times. So I'm simplifying as I go just to save myself some time. So now I'm going to do 5 times 45, and I'm going to get 225 over 2, because 2 times 1. Pi turned into 1. Now this I actually will write out as a decimal because number 1, it's a nice decimal, and number 2, we're looking at degrees here. So we're not changing it to an irrational number. We're going to write it as 112.5 degrees. So degrees you'll see more often written in decimal form. You'll never see radians in decimal form. So that's a dimensional analysis method using my understanding of equal values and scaling things up and down. But now if I would like to look at the proportion method, I would again set up, let's see, pi over 180 equals 5 pi over 8, so radians on top, over x. So now I'm going to cross multiply, and I'm going to multiply these two and these two. We get pi x equals 180 times 5 pi over 8. Again, it's going to be the exact same math, so I'm not going to go much more into depth here, because I'd simply start to cancel again, dividing both sides top and bottom by 4, and then I would multiply these two to get 225 pi over 2, equals pi x. And notice then I would simply just cancel out the pi's, and I would get the exact same answer as I did using the other method. So you pick your method. Either way, it's going to involve multiplying and dividing and simplifying fractions. Just pick a method that you'll think will work for you every time. So the next thing that we need to understand is coterminal angles. That's the last objective of this video. So coterminal angles are really, the word co means to share, and of course terminal, the terminal we've been talking about is where the final side of the angle. So for instance, this was the initial side of the angle, 60 degrees. This was the terminal side. So coterminal means they share the same terminal edge. So 60 degrees and 420 are coterminal because 60 degrees opens from here and it ends at the first terminal side. 420 is really just a full circle plus 60 degrees. So I went the full circle, and then I went another 60 degrees. That is coterminal because they both land in the same spot. They both finish in the same spot. Another set of coterminal angles are positive and negatives. There's always a positive and a negative coterminal angle. This is 240 degrees. It's coterminal with negative 120 because, again, they share that same terminal side. So every angle will always share the initial side because we're always starting them on the x-axis, but if they land in the same spot on the terminal side, we call them coterminal. So the major rule is that you can take any angle and add multiples of 360. That's what they mean by this k right here. You could add a full circle, a half, you could add any full amounts of circles, or you could actually subtract full circles. That's why they write plus or minus 360k. So looking at a couple of examples and how we'll use this, if I want to find something that's coterminal with 390 degrees, and if I read the instructions, it wants a positive angle less than 360. So 390, all I have to do is add or subtract 360 degrees because that's a full circle and it will land in the same spot. So I'm going to subtract 360 and see that 30 degrees is coterminal with 390. B, I'm also going to subtract 360 because I see that it's bigger than 360, so I'm going to reduce it by 360, and I see that 45 degrees is coterminal with 405. 135, or negative 135, is a little bit different because now it's less than 360. So I'm actually going to add a full circle back in and see where I would land. I would land at 225 degrees. So this angle and this angle are coterminal. They both land in the same spot, and I could draw a sketch. Negative to see that I'm right. Negative 135 is here because it's 90 plus another 45. 225 positive is 180 plus another 45. So the adding of the full circle allows me to land in the same spot. Okay, so adding a full circle back on will always give me that terminal side identical. Now, of course, we aren't just going to be working in degrees, we're also going to be working in radians. So if we're doing radians, now instead of adding 360 degrees, we're going to add 2 pi or add negative 2 pi. Since they want it less than 2 pi, I first have to decide, is it bigger or smaller than 2 pi right now? A says 5 pi over 2 if you can't read that. That's bigger than 2 pi, so I'm going to subtract 2 pi to find a coterminal angle. But of course, I need to get a common denominator in order to do this. So I'm going to do 5 pi over 2 minus 4 pi over 2, because that's equivalent to 2 pi. Subtracting that, I get pi over 2, because 5 minus 4 is 1, and then of course the denominator stays the same. So pi over 2 is coterminal with 5 pi over 2. Letter B is 11 pi over 4. Again, I first have to decide, is this bigger than 2 pi or smaller than 2 pi? And it is bigger, because 2 pi would be like 8 pi's over 4. So what I'm going to do is I'm going to subtract 2 pi's to get less than 2 pi. But of course, 2 pi's is really 8 pi over 4, so I'm going to change that denominator again. So this is 11 pi over 4 minus 8 pi over 4, which is equal to 3 pi over 4, because 11 minus 8 is 3. Last one is obviously smaller than 2 pi because it's negative pi over 6. So I'm going to add on 2 pi's to find something that's coterminal. Add a full circle. 2 pi's is really, let's see, 12 pi over 6, because I times top and bottom by 6. So I'm adding 12 pi over 6 to negative 1 pi over 6. So I'm going to get 11 pi over 6. So your fraction skills are going to come in really handy here, being able to work with equivalent fractions and changing denominators. So be prepared to practice that this chapter. So last but not least, here is your checkpoints for the video for today. So your first one is convert the angle to radian measure, and that would be 135 degrees. Convert that to radians. And then find an angle between 0 and 2 pi radians that is coterminal with 12 pi over 5. So give those questions a shot. Bring your answers into class, as well as any questions that you may have.